give you a second chance for both homework assignment 1 and the midterm. Yeah. Yeah. I mean, for those students, several students did very well. Yeah, this class, I noticed about 4 students doing quite well. Okay, 4 or 5 doing quite well. Yeah, so they may not need, but they can still get a few points back, right? Yeah. All right. But for other students, yeah, so I plan to give you second chance, yeah, first for these 2 assignments. Yeah. All right. So second chance, 2 assignments. Yeah. First one, homework 1 assignment. Second, midterm, part B, right? Part B, yeah. Part A, yeah, yeah, yeah. The quiz thing, so no second chance. Midterm, part B. Part B, 15 questions. Yeah. All right. So basically, for those questions, if you miss more, greater, or equal to 2 points, then if you only lose 1 point, then you do not do it. Okay? That means 1 minor mistake, right? Minor error. So then we don't do it. Okay? Only for, all right, so for those questions, you can get points back, half point. So for those questions, lost greater or equal to 2 points. Okay? To explain your own ideas, you need to understand the solution by yourselves. It's not, you copy, because I provide you my standard solutions. Yeah. You need to understand to get your own understanding. So you need to use your own words to explain to me, okay? So you, based on your own understanding, so your explanation, okay? Explain. Using your own words. Okay? Yeah. Because here, I emphasize understanding. Yeah. So not, just copy results. That's not good. So with understanding, so you make it your own knowledge. If you have the understanding, that becomes your own knowledge, right? Yeah. You can use it. Use that knowledge, you can solve other problems. That's the, importance. If you just, copy existing solutions, then you cannot use that to solve other problems. Yeah. So that's the main difference. So using your own words. You need to spend time. So you can ask your friends or ask me, if you have questions. If you couldn't understand the solutions, you can ask other people. okay? Yeah, including myself, yeah. Yeah. Just to make sure you understand all the solutions. Yeah. All right, yeah? Yeah. So for both homework 1 and midterm part B, yeah. On Canvas, I plan to create 2 no-score assignments to keep track of this information. Now, I will, how do I keep track of, right? So I plan to create 2 no-score assignments. I need to create assignment, but no points, 0 points, okay? For each one, 0 point. But for each student, under your name, I will write, so you have these questions, yeah, so I will write down, yeah, because I look at your, if you lose more than 2 points, yeah, I will, so you can recover points from these questions, 1, 2, 3, 4, 5, okay? I put a list there, yeah. So you there, so you write a document, you write a file, okay? You write your understanding. So I give you about 2 weeks, okay? I'll give you about 2 weeks to do that recovery, okay? Points recovery work, yeah, 2 weeks, yeah, about 2 weeks, yeah, yeah. So about 2 weeks, okay? You know, yeah. Try to, yeah. If you need a little more time, that's okay, okay? Not very strict, yeah. But make sure you do quality work, okay? You do some quality understanding work. Yeah, all right, so there. Yeah, so make a file. Yeah, then you can submit. Yeah, submit, because although it's a no point assignment, you can still upload the file, right? Yeah, so you upload the file, then I do grading. Yeah, on that grading, I check if you pass the requirement. I look at your understanding is good or not. Yeah, if it's good enough, I give you that 50% points for that particular question, okay? I do question by question. Yeah. This one, I give you, 50% points back, one by one. Yeah. Yeah. And at the end, I collect these points. I can add to your, homework 1 and add to your midterm part B. Okay, at the end, I can do that. Yeah. But here, I do good bookkeeping. Yeah. These 2 assignments, I do bookkeeping. Okay, yeah. So also, your current status, yeah, for the recovery part. Yeah, yeah. All right. So that's one. Yeah. But another thing, yeah, because I look at the midterm part B. Yeah. For your class, slightly better than the other class. Yeah. I have an online class, so that class, many students, they didn't understand most of the questions. So that's not good. I also give them the second chance. They need to do that. Yeah. But another thing is, I try to use the question of midterm part B. I try to make sure each student, yeah, so I will run some, I treat this part as the training process. So after you finish this class, you need to understand all the questions from midterm part B. Okay? Yeah? So those students, so if you do not, yeah, because use this recovery process, that's the first round understanding. After that, after first round understanding, remember, we will still have quizzes, right? We will still have 3 quizzes, 1 homework assignment, and 1 final, right? In these remaining assignments, I will give you some of the midterm questions, yeah, but I will change in different formats. I will check those students if you can still solve them, okay? That's the remaining chances in this semester I can use to check your understanding, okay, for all those students. Yeah. If I notice some students still couldn't understand that, so, I may ask them to do some more work. Okay? Yeah. So at the end, I try my best to make everyone understand all midterm Part B questions. I only focus on midterm Part B questions. Yeah. Yeah. So I keep track of them. Okay? If we pass one, I check it. Okay? Check questions. Yeah. But in later assignment, I will assign you modify the questions to check if you really get it. Okay? So that's my plan. Try to do some quality control. This is my quality control. Okay? Yeah. I don't want to see after you finish this class, you cannot solve some basic questions appeared in midterm Part B. Midterm Part B I treat as basic questions. Okay? So our standard questions. Yeah. So if some students cannot solve those questions, we treat as failure. Okay? Failure of the training. Yeah, we treat as failure of the training. So here I give everyone plenty of chances. You keep practicing. Just focus on these 15 questions. Keep practicing. At the end of the semester, you need to make sure you're passed understanding checking for all these 15 questions. Yeah, that's my plan. Okay? Yeah. Yeah. For those good students, you don't worry. Yeah, but here I for those students, who had hard time on these 15 questions. Yeah. For 2 classes. Yeah. Not just for your class. Your class a little better than the other class. Yeah. 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 That's my plan. You can tell me your feedback. Yeah. So this is my current plan. Yeah. I know we need to do a lot of work, both you and me, because I need to do a lot of grading, right? Extra grading. Yeah. But I want to do the last push for the quality control. Yeah. I think it's worth it. For both of us, worth it. Worth your effort and worth my effort. Okay? Yeah. Yeah, think about that. Think about that. Yeah. The bottom line, each of you have plenty of chances. You don't waste those chances. Yeah. For all students, don't waste those chances. Okay? Understanding chances. Yes, understanding chances. Before the semester ends, you have chance. This semester, you don't have chance. Okay? Don't waste that. Don't waste those precious chances. Okay? Yeah. All right. Yeah. So this video I will let other class, online class, let them understand English. Okay? All right. Yeah. So that's what I like to talk about this, this training. I treat as, special training session. Yeah. Although usually we do not have this kind of training session. But so many students fall behind. So I have to do this special thing. Okay? Try to help them, push them, lifting them up, passing the line. So we have some standard, right? Base standard line. Try to lift them past that standard line. Yeah. Okay? All right. Yeah. So that's the plan. Yeah. All right. Yeah. So let's start our new Part B, binary search and selection problem. Yeah. Here you can see the topic. Many of you know this topic. Yeah. Here, but we look at this topic again from divide and conquer approach. This point of view. Yeah. So we try to learn. Yeah. So although if you are familiar with this method, that can improve problem solving skills. Yeah. Yeah. So here, for the remaining of the semester, I will still assign you many such questions, so you know the logic puzzle questions, right? So that means how to use the minimum number of comparisons to find some special elements. Okay? Yeah? Yeah. Later you will see find the median, for example. Sort an array, right? Find the second largest, find those special elements. Yeah. So we will have more those questions. Yeah. So this part, divide and conquer, we can learn some, more techniques to solve those questions. Yeah. All right. Problem number 11, search an ordered array. The problem, binary search, so given an ordered array, and a search key V. How to find an index I such that V equals A of I. Yeah, so that's the, the problem description. So very simple. Yeah, all right. The solution, you know the solution, yeah. But here, I like to, explain, some special views. Yeah, here. Yeah. All right. Let's do analysis. Yeah. The idea here. Yeah. Reduce the problem size by the ordered data property. The basic idea still, so here you can see it's very common that we use this idea to solve problem, reduce the problem size. Yeah. It's a common strategy. Yeah. The question, how do you reduce the problem size, right? There are many different ways to reduce the problem size. Yeah. 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 All right. Yeah. So here, we use the elimination method to do size reduction. Yeah. Yeah. Elimination. Another method we use frequently, right? Yeah. So you can look at our midterm Part B, how many questions we use elimination method. Yeah. Yeah. So many. Yeah. And later, when I assign you new questions, you will see we have many questions we need to apply this method. Yeah. All right. Question. How can we take advantage of the ordered data property? Here, this property is very useful. Here, we want to take advantage of this property. Yeah. This property can help us make good prediction. Yeah. Yeah. With this property, we can make good prediction. There, we can eliminate as many elements as possible. You want to eliminate more and more elements. Yeah. Yeah. All right. Explore the order property here. Okay. All right. So here, let me use this simple diagram. Yeah. All right. So here, this is our typical situation. We have the V search key. Yeah. Then we have this ordered array. Yeah. Now, we want to find which element in the array that equals this search key with the minimum number of comparisons. Now, with, general minimum number of comparisons. Okay? Yeah. All right. So here, let's consider your first comparison. When you start, you need to do the first comparison. The question is, which element we should pick to do the first comparison? We have many freedom to choose, right? Yeah. Any element we can pick as the first element to do the comparison. Yeah. But some element is better than other elements. Yeah. So this is our first question. Yeah. All right. Yeah. So here you can see, when you have so many different choices, then how to make the best decision. Yeah. how to make the best overall decision. Okay? Yeah. So here, there are several interesting views we can use in this situation. Several interesting views. Yeah. So let me talk about those views. Okay? All right. Question. After one comparison, how many elements can be eliminated? Yeah. So let's just look at a typical situation. After just the one comparison, the first comparison, how many elements can we eliminate? Yeah. 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 Remember our homework assignment last question and our midterm last question, we do that, right? Yeah. I only give you the information for one comparison. A2, compare A2 with B3. Yeah. Then ask you how many elements can be eliminated. Yeah. Yeah. Here, we also look at that question. Yeah. Yeah. All right. If the first element you compare is the last one, A sub n minus 1, last one, yeah, there you have two possibilities as your comparing result. Yeah. Yeah. One possibility, V greater than, strictly greater than. Okay? Another less than or equal. Less than equal, so there we put a, one side. Strictly greater than, we put another side. Then the strictly greater, that side, we can eliminate, right? Yeah, because that part, there is no chance that subarray could contain the given element V. So we can completely eliminate it. Okay, all right. Yeah, yeah, but here, yeah. So what do we see? Yeah. Oh, actually, so here the situation. Yeah. Here, I may need to modify. Yeah, because I wrote the best case. I wrote the best case, so I need to fit this situation. So this left-hand side is strictly less than. Right-hand side is greater or equal to. It should be like this. Strictly left-hand side, we can eliminate it, right? Left-hand side, all gone. All eliminated. Then, right-hand side, only one element left, right? That's the best case. That is the best case. Yeah. That's what I mean, the best case. Because you eliminate large portion of the subarray. Not that smaller portion. You eliminate that larger portion of the subarray, subarray with the larger portion. Okay? Yeah? Yeah. So that's the best case. Yeah. All right. But can you expect to have this result all the time? You cannot, right? Only when you are lucky, you can get the best case. In general, you cannot get the best case. Yeah. In general, you cannot get the best case. Yeah. Here, the view related to this specific situation, I may like to use several views. The first one, I like to use the adversary argument. Yeah. I want to remind you, I talked about this before. In order to get a worst case, we create imaginary smart adversary. So here, I apply that adversary argument again. Argument. Yeah. So let's use that imaginary adversary. Yeah. Here, when we do comparison, we have two possibilities, right? How to get the worst case? We ask our adversary, which side you want to give us? Okay? Which side you choose? We ask the adversary to choose the side that contains the given key. Because the given key can only appear in two of the subarrays, right? Two subarrays, either left subarray or right subarray. Yeah. But which one to take, we do not choose by ourselves. Because if we choose, we want to choose the one to our favor, right? Yeah. But our adversary is always fight against us. Our adversary never does any favor for us. Never. Our adversary always try to make our lives harder. Yeah. So our adversary will choose the larger subarray to contain the given key. Yeah. Yeah. So that's the strategy of the adversary here. Okay? So if you compare with the last element, our adversary would tell us the larger subarray would contain the given key. So then you need to do more work. So our adversary would force us to do more and more searching work. Yeah. Okay? All right. So that's the typical adversary strategy. Yeah. Then, what's our strategy to fight against adversary? Okay? Yeah. We have freedom to choose our strategy to fight against that adversary. Okay? Yeah. So here, we choose a strategy. Yeah. So our strategy, if we split the subarray somewhere in the middle, after that split, both subarrays, they have equal size. Then, this time, when we ask our adversary to choose which side you want to give us, then no difference, right? Because the both sides of equal size. Yeah. The difficulty to search the key in each one, same difficulty. Okay? That's our strategy to fight against the adversary. Okay? So that is when we have freedom to choose, we want to make the most balanced choose. The balanced way, the most balanced way. Yeah? So the array we cut in the middle, that's the most balanced split to fight against our adversary. Then the adversary, no matter which side you choose, the same. That's the best strategy against the adversary. Okay? All right? So that's this view. Okay? This interesting view. In problem solving, especially when you work on the worst case situation, this view may help. Okay? This view may help. Yeah. All right. Then, all right, next, yeah, so here we talk about these cases. Well, another view, there are several views we can use to understand. Another view, it's like Murphy's Law, right? Yeah. The Murphy's Law also, you can use the similar idea to understand, because the Murphy's Law tells us anything that can go wrong will go wrong. That's the content of Murphy's Law. Here, anything go wrong, yeah, because the larger subarray that contain the given key, that's the wrong part, right? Yeah, that's the worst part. Worst part, let's treat as the wrong part. Okay? So the Murphy's Law tells us, yeah, you need to worry about that part. Okay? Not the easier part. Not the smaller subarray, the easier part. Yeah. You need to prepare yourselves to the harder part. Yeah. The larger subarray, that part. So that's based on the Murphy's Law. We can also understand the strategy. Yeah. Yeah. Okay? All right. Yeah. All right. So compare the one right in the middle, that's the median. Yeah. So here, yeah, we will use this median concept. Yeah. Yeah. So when we talk about median, so here, let me just explain a little, by the meaning of this median. Yeah. When we have odd number of elements, then no argument, right? The median is the one right in the middle, so no confusion. When we have odd number of elements in the array. But when we have even number of elements in the array, what's the meaning of your median, right? Yeah, so here, let me clarify it. Yeah. Because this median definition, yeah, many students, they have different understanding on this median definition. Yeah. Yeah. Here, let me talk about our specific definition in this class. Yeah. Yeah. All right. Here, let me just consider the case with even number of elements, array with even number of elements. Yeah. So let me just draw 4 elements, okay? Yeah. So it's good enough. Yeah. All right. Yeah. So the y in the middle, because these 2 elements, they have the same distance to the center of the line segment, right? Same distance to the center. Yeah. So, yeah. Which one you treat as the median, right? Yeah. Yeah. All right. So our definition. Yeah. Yeah. First, these 2, because they have the equal status, equal situation. So one we call the left median, the other we call right median. Okay. Yeah. So one is the left median. Yeah. Left median. The other we call the right median. Okay, all right. So 2 medians, yeah. But another level. Left median is the default median. Okay? Left median is the default median. So if we do not say left or right, then we use left median as our default median. Okay? Yeah. So for even number, yeah, for this class we use this understanding. We do not use other understanding. Yeah. I saw some students, they use the different understanding. Okay? Yeah. One way they use from their, grade school. Yeah. Because some students, they still remember in their grade school, they learned the median definition. That definition is the average of left median and the right median. That's their grade school definition, okay? Left median plus right median over 2, yeah, that's the typical grade school definition. Yeah. In math, many times they use this way, but in computer science, yeah, especially in our computer science, we never use this definition. Okay? In math, yeah, many people use that definition. So in CS, computer science, never. Okay, never use that definition. Yeah. The reason is simple. Let me explain the reason. The reason is simple, yeah, because in computer science, when we talk about a median element, that element must be one of the elements in the array. Okay? It cannot be the, something outside the array. But if you take left median plus right median divided by 2, in general, that's outside array. That cannot be inside array, right? Yeah. Left median plus right median divided by 2, that's not an element inside the array. Yeah. But in our CS, we need a specific element that corresponds to the median inside a given array because we need to use it. We need to use that median element in many implementations of our algorithms. Okay? Yeah. So that's important for computer science context. Okay? Yeah. So here, let me clarify it. Yeah. So from now on, then it's clear, right? The median is clear. Even, odd, it's no confusion. anymore. Yeah. All right. Yeah. The strategy, balancing principle. Yeah. Here, when we have freedom to choose our data split, we want to make the most balanced split. So this principle, okay? The most balanced split corresponds to the overall best efficiency algorithm. The best overall efficiency algorithm. The balanced split. Yeah. Yeah. But sometimes we may not be able to do the balanced split, right? Yeah. Many times we cannot do the balanced split. Yeah. Sometimes we can do that. Yeah. All right. Yeah. Yeah. So as a result, now if we do this balanced split, yeah, right in the middle, yeah, at the median, then every time we can eliminate, we apply the elimination method, we can eliminate approximately 1/2 of the data. 1/2 of the data. Hmm? Is the time not correct, right? Yeah, I need to use my cell phone. Yeah. I need to use my cell phone to monitor. Oh, yeah, right. The sunlight, right? They saving time. So, yeah. Oh yeah. Yeah, daylight. Yes. Okay. All right. Yeah. Yeah. So let's try to complete this binary search. Yeah. B.2, efficiency analysis of binary search. Yeah. All right. The idea is simple. Yeah. Now let us do efficiency analysis. Yeah. Draw some diagram. Let's look at the number of comparisons for the worst case. Yeah. Yeah. Here, most people know approximately the number of comparisons for the worst case, but most people do not know the exact formula. They know approximate formula. Okay? Yeah, approximate formula, everybody knows. Yeah. Everybody knows the number of comparisons for the worst case. Log base 2 of n, right? Log base 2 of n. Okay? Yeah. Yeah. But our first question, we want to know exact number. Yeah? Because this number first, usually it's not an integer. If you want to make integer, you have many different ways, right? You can use a floor function, you can use ceiling function, or floor function. Which function do you think is correct for exact number of, worst case comparisons? Floor function, ceiling function? Yeah. Which one is ceiling? Yeah. Actually, both not exact correct. Both not exact correct. To make exact correct, you need to modify slightly. Even ceiling function, you need to do +1, -1, some, add a little bit. Yeah. So that exact formula, most of the students, if you do not learn this topic, it's very likely, 90% of the time, it's very likely you do not know the exact formula. Yeah. So after this class, yeah, you learn that formula. Okay? All right, so let's look at that formula, exact one. All right, this line segment represents the whole array. Okay? Yeah, the length of data size. Yeah. First comparison, compare. Yeah, here we do approximation. Yeah, here we just represent the idea. We do approximation. Okay, yeah, but that approximation is good enough. Yeah, all right. Then we drop 1/2 of the array. Okay, after one comparison, we draw approximately 1/2 of the array. So the size reduction, if the original array, the size is n, now it becomes n/2. Yeah. First comparison reduced the data size of original by half. How about the second comparison? Another half, 1/4. So we have 1/4 of the original data size after 2 comparisons. Yeah. All right? How about keep doing this a few times? Yeah. All right? After K comparison, what is the data size? Yes. Here, let me do this chart. Yeah. Under each comparison, you have the corresponding data size. Yeah. After K comparisons, the remaining data size n over 2 to the kth power. 2 to the kth. Okay? Yeah? All right. Yeah. Yeah. Think about that. Yeah. So that's the, approximate data size representation. Question. On research, we want to locate the last comparison. That is, after that final comparison, we're done. We want to figure that out. That corresponds to the worst case efficiency, right? That corresponds to the worst case. So we want to get the condition for the last comparison. So how to make that condition for the final after final comparison? What is the data size should be? Yeah. 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 That point is critical. We need that end point. Termination point. We need that. Okay? After last comparison, the data size should be strictly less than 1, right? Yeah. Because if the data size equals 1, it can still cover 2 elements, right? Yeah. Because the length 1, the distance between 2 elements, if it's 1, there is a possibility it covers 2 elements, right? If 2 elements, you can still do another split. But if the data size is strictly less 1, then you can only cover at most 1 element, right? Yeah, that little line segment, the line segment corresponds to the data size, can cover at the most 1 element. Then you cannot do one more split. Okay? So that's the equality. That's the inequality we use to try to find the last comparison. Yeah. All right. Yeah. See, yeah. So after kth comparison, yeah, the data size is this. So this number should be strictly less than 1, but its previous, the data size of its previous comparison, that size should be greater or equal to 1. That K would tell us the end point, the termination comparison, the last comparison. Okay? So this inequality is important for us to identify the worst case number K. That K corresponds to the worst case number of comparison. Yeah. So we want to work on this inequality. Okay? Let's simplify this inequality. Yeah. All right. Yeah. So after we remove the common denominator, so we get this inequality. Yeah. Left-hand side less than equal, right-hand side strictly greater than. Yeah. That's important. Strictly greater than. That's important. Yeah. Okay? Yeah. Because we only consider integers. N is an integer between these 2 adjacent power of 2 numbers, right? Yeah. Here, inequality, left-hand side, right-hand side, they are power of 2. They are adjacent power of 2 numbers. Okay, all right. Then let's look at the range for the K number, range. Yeah. Because our goal, we want to get the K representation. Yeah. All right. So let's take log base 2, so we get this formula, log base 2. Okay? Yeah. Now we try to make it, try to get an inequality about K. Okay? All right. Yeah. So we are here. Okay? Yeah. So now we are here. So our starting point, we start from this inequality. Yeah. All right. Then, let's look at the K range. Let's look at the K range. Yeah. When we solve this inequality for K, so we get this new inequality about K. Yeah. K less than or equal to 1 plus log base 2 of m. But this expression is not necessarily integer, right? It's not necessarily integer. Yeah. Our K is an integer. Think about if this representation is not an integer, then K must be strictly smaller than this number, right? K cannot be equal. Yeah. So you can see we should take floor function, right? Floor function, moving down. We should not take ceiling function, right? Moving up. In order to make the expression closer to the K, we should round down. Round that right-hand side function down. Okay? So we take floor function this time. Okay? All right. But how about this side? This side, here, strictly less than K, that means it's not accurate. If it's strictly less than K, there is some small room to change. Not accurate. Yeah. All right. So here, let's go back to the original equation. Before we let's look at the inequality before we take log base 2. Because we have some room to improve this inequality. Yeah. Improve right here. Yeah. Can we tighten this inequality a little bit? Tighten, make it tighter. Tighten a little bit. How about this power of 2, 2 to the K, minus 1? Can we reduce by 1? Power of 2? If we reduce by 1, it should be greater or equal to K, right? It cannot be less than the largest n, right? Yeah. It's still greater or equal. Yeah. So we can tighten inequality by reduce it by 1. Or just the n plus 1 less than or equal to 2 to the K. Yeah, the same. Yeah. All right. So with this new inequality, this one, then let's take log base 2. This time we get log base 2 parenthesis n plus 1 less than or equal to K as the lower bound. The upper bound is the same as before. Lower bound, we improve slightly. We make this parenthesis n plus 1. After we change to n plus 1, we can change this original strictly less than sign to this less than equal to sign. Improve a little bit. Okay? All right. Because it can equal to that K, yeah. If this function is not integer, then we can take ceiling function. Moving up, right? Rounded up to approach that K value. Okay? So, the left-hand side, we need to do ceiling function. Right-hand side, we need to do floor function. Okay? Yeah. So, the conclusion, we have two possible formulas we can use to represent the worst case K number. Yeah. The first one, Kmax. Here, I use Kmax, maximum number of comparison. For the worst case, that's the worst case number. Okay? The Kmax equals the floor function of log base 2 of m plus 1. Second formula, Kmax equals to 1 plus the floor function of log base 2 of n. These two formulas, they are the exact formulas. They are equal. First, these two formulas are equal mathematically. Yeah. So we can prove it. We can prove they are equal by mathematical induction. Yeah. Yeah. Here I skip that part. Okay? Yeah. So here I do not do that proof. Yeah. Yeah. It takes some time. Yeah. But it can be proved. So these two formulas, they are the same. You can use either one. Okay? Either one is correct. Yeah. Okay? Yeah. So here you can see, usually people, yeah, so here you can see, for the binary search, it's very common, people most likely they use one of the two formulas. Yeah. So you can see if people use their common sense to write worst case formula for the binary search, these two versions. One is ceiling function log base 2 of m. Another is floor function log base 2 of m. Right? So in a natural way, people tend to write, because they know they are integers, so they use floor function or ceiling function directly on log base 2 of n. But you can see both formulas are not exact as our binary search worst case, the final formula. Not exact. Okay? So the exact, these two versions, changed slightly. Makes slight change. Yeah. Okay? Yeah. So then, now, let me ask you a simple question here. Yeah. After you know this formula, now let me ask you, yeah. Given an array with 64 elements, now we want to do binary search. How many comparisons do we need for the worst case? 64 elements. N equals 64. How many comparisons you need for the worst case? 7. Yeah, not 6. 7, not 6. Okay? Yeah. If you use either of these two formulas, you would get 6, right? Yeah. But if you use one of these two correct formulas, you will get 7. Okay? You will get 7. Yeah. Yeah. All right. Yeah. Yeah. But because based on my experience, I ask my students in other different classes, when I have a chance, I make a question, binary search, with, so most of the time people use one of these two formulas. Okay? Yeah. Yeah. Not, how can they get that precise formulas, right? Yeah, it's hard to imagine. Yeah. Yeah. All right. Yeah. Yeah. So the second, yeah, we just talk about the worst case, right? The best case, easy, one comparison. Yeah. You compare to one comparison. Yeah. All right. So then next, another important concept I want to let you practice is average case efficiency. After you know the best case, the worst case, how to get the average case. Yeah. That may not be easy. Yeah. Yeah. Many times it may not be easy. Here, not that straightforward. Yeah. Let me ask you another question here. Yeah. Yeah. Here we know, so these two cases given, so yeah, you know that. Yeah. Next question about average case efficiency. Yeah. So my question is, can we use the average of the best case and worst case, this one divided by 2, for the average case efficiency? Can we use this formula to calculate the average case efficiency for the binary search? Yeah. Answer is no. Yeah. Answer is no. That's correct. But can you explain a little bit why the answer is no? Yeah, not linear. Yeah. Because the binary search, if you draw, yeah, because the binary search, you arrange your elements in an array in a binary tree. Binary tree typically like this triangle shape, right? Yeah. Top level only one element. Then the next level 2 elements. Next level 4 elements. So this kind of triangle shape, the elements distributed not evenly, right? Yeah. If it's even, yeah. So if the elements distribute like this, all levels the same number, then you can use this average to calculate. But in that triangle distribution, not evenly, favor the bottom, right? Yeah, because you have more elements at the bottom level. So the average would closer to the bottom level, favor the worst case, right? Yeah, favor the worst case. Yeah, yeah. So here you get an idea. Yeah, because the weight at the lower level will be larger than the weight of the higher level. So that would mean average case number would close to the worst case. Yeah. All right. Yeah. More specifically, what is the average case efficiency? More specifically, here, let me give you an example. When n equals to 7, let us do some calculation. When n equals 7, it's not hard, so we can handle it. Yeah, small number of elements. Yeah. So in my next slide, let me calculate the average number of comparisons for the binary search when n equals 7. Yeah. All right. B.3, yeah. Average case efficiency of binary search. Yeah. All right. Yeah. So let's consider our data 7-element sorted array. Yeah. So let's draw the binary tree. Yeah. Corresponds to our comparisons for different levels. Yeah. These 7 elements, let us use number 1 through 7, okay, to represent 7 different elements. Yeah. All right. Then, the first comparison, when we do the first comparison based on the binary search, it should be element number 4, right? So that element should sit at the root, the top level, root. Yeah. All right. So let's draw the binary tree. Yeah. Here, yeah. So here the probability. So we assume, the search key is contained in the given array. Yeah. Otherwise, we need to use that P to do the calculation. Yeah. All right. Yeah. All right. Yeah. So element 4 is at the root level. Only one element at the root level. Okay. All right. Then we move down. The next level, 2 elements at the next level. Yeah. So in top level, 1 comparison. In order to find a match at the top level, we need to do 1 comparison. Yeah, so this 1 number there. Okay. All right. The next level, node element 2 and element 6. The next level by the binary search, right? Yeah. The median of left subarray, the median of right subarray. Yeah, these 2. Yeah. So to match one of these 2 elements, we need 2 comparisons, right? outside dangerous, right? Yeah. Inside okay, right? Yeah. 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 So, all right. Yeah. Yeah. 17. Yeah. All right. Yeah. So let's continue. Yeah. All right. Yeah. Then another lower level. Okay. Yeah. All right. So all the remaining 4 elements at the bottom level, and they correspond to 3 comparisons. Yeah. All right. Yeah. After we draw this binary tree, is it good enough? We can calculate average case efficiency based on this binary tree. Yeah. Now we are ready to calculate the average number of comparisons. Yeah. Collecting all the levels formula. Okay? All right. The denominator 7, numerator top level number of comparison contribution 1 times 1. Yeah. Each one comparison, 1 times 1. All right. Next level, there are 2 elements. Each one 2 comparison contribution. Okay, 2 by 2. Yeah. Then next level, each one 3 comparisons, but you have 4 total. So 3 times 4 number of comparisons. Yeah. So there, the final average number 17/7. 17/7. Okay? Yeah.
One's been spotted. Tornado hasn't quite. One's been spotted. I don't know if that's touchdown.
There's a funnel cloud.
Yeah, funnel cloud's begun. I don't know if it's touchdown, but a tornado's been spotted. Fun.
Do you know what should we do in this situation? Basement? Oh, we're in the basement.
Bottom of the building. You can go into the tunnels underneath.
So what you want to do is you want to seek the lowest location that also has, that's as far away from windows
Which
facing
would be
outside as
straight
possible.
that direction for every
It would
building.
literally just be in this hallway. There's probably markers.
Yeah, you can get further into the building, just a little bit over, but that would be more.
I mean, probably the computer lab would be pretty solid.
Computer lab probably.
Because there's
If
no,
it's one right across the hallway.
yeah,
Yeah.
there are no windows.
Let's just check Twitter while the building collapses.
Yeah. Let's stop right here, yeah, because, safety, higher priority.